up, Clean Freight, the Tank Bulge? We're back in studio with our water quality expert, Jeffrey Paquet. Welcome back to the show, Jeff. So we're talking about water monitoring, water quality monitoring in this episode, and I gave a little teaser at the end of last episode and said, this is one that I know the inside Jeffrey Paquet is just going to come outside, and we're going to see just the animal like the Hulk unleashed on this water quality question. So I'm really looking forward to this episode. I don't know if that's a good description or not, but we're going to run with it. So anyone who is jumping in, though, to the middle of this conversation, I want you to hang with us, because monitoring is something that you should be doing no matter what. Even if you don't have a plan, if you don't have a multidisciplinary group, you should be watching your water. So you're going to get something out of this conversation no matter what. But what I definitely want you to get, if you've missed earlier episodes, is the fact, there's a lot more going on to this monitoring question than just what are we doing in the apartment? Is there someone watching our waters? Like, what's the goal of all this? What's the team behind it? How are you surveying? Do you actually know the risks inherent in this monitoring piece that you're trying to keep within these certain guidelines? And so you're going to have value here. We're going to get more value going back and watching the previous episodes, and you can track those down on the Beyond Clean website if you missed them. Okay. Monitoring water systems and identifying those controls in our departments. Jeff, what are we talking about when we say
monitoring? Well, first of all, I'm going
monitoring?
to try to keep my shirt on here and turn this whole thing. I'm not going to, that.
Yeah, that's right. No
so when we're talking about monitoring, what we're talking about is trying to take an approach that is not unlike playing zone defense, right? We're not trying to play man-to-man. We're not looking at everything. We're looking at sort of a subset of some indicators of water quality that'll give us assurances that there's a high probability we're okay. It's not unlike when you do your QMS process on instruments and use bioindicators. You're not using a bioindicator on every instrument you process. You're checking lots. You're doing a statistical approach to managing quality and monitoring it, and that's exactly what we're doing here with water. So, and when we're talking about water quality monitoring on a monthly, quarterly, or yearly basis, you're referring to tables 4, 5, and 6 in the SD 108 standard. There is a table at the beginning, table 2, which is important, but that is not something you're going to use on an ongoing basis, so don't get confused there. We're looking at tables 4, 5, and 6. And basically, we're looking at 7 indicators of water quality. And across the 3 types of water used in the department defined in the standard, which is utility water, which is just the water that you're using in the sinks to soak and process some instruments, doing a lot of your washing, cart washing. And then we're talking about critical water, which is your final rinse water, and then steam, the quality of steam indicated by steam condensate, which is obviously what's used in sterilizers. And we're basically looking at these indicators at different points in the process and assuring ourselves that we're on track. When you get to the owl, who does this? The owl in the hospital, whose job is that? That needs to be clearly defined in your water quality management document that you develop. By the time you're getting to water monitoring, you should have a developed program for monitoring it. And it should be very clear who's going to do it. Now, a lot of people hire outside companies to come in and sample water and provide them results. Some departments actually sample the water themselves and then send it off to a lab. Sometimes that's managed by facilities. You are going to have to determine up front how that is going to work for you. And then, as everything else with a water quality management plan, as you get down the road, if it's not working, you're going to change it and revise it and make it work better for you. But you will have to identify how that's going to happen.
His next question, I think you answered on the sampling piece, but is there such a thing as real-time quality monitoring today, or is it just the sample process that you mentioned? Is that kind of the most common best practice that we're seeing out there?
Well, certainly sampling is probably the most current comprehensive practice out there, simply because monitoring can often be expensive, and it's relatively new. We're familiar with looking at conductivity monitors probably for our critical water, or seeing the little light come on our DI tank. That's a quality monitor indicator. But there are very sophisticated ways, and what you will often see for monitoring is actually all of the stuff that's sort of buried in Appendix G having to do with water treatment equipment, which is it'll be process oriented. So it's not about checking the product, which is the pure water. It's about checking that the process controls and the pieces of the process are running to spec to produce good water. So you're monitoring the process, not necessarily the product, like most quality management systems are.
And you mentioned the who in this process. And so if I'm understanding this correctly, the process itself is going to be dependent on somebody, a human, if it's sterile processing, if it's an external vendor, if it's facilities coming in, but somebody's coming into our departments at these sample points. They're taking the sample at the regular intervals, and then they're going off to the lab.
That is
doing
correct.
The testing
and I will
from there.
caution people on sampling. It is not trivial. It is the part in the process that can break down the quickest and the easiest, because they're taking action on bad data is almost worse than not having the data, right? And so there are very specific standard operating procedures for sampling water that it's science. It's like a surgery. You have to follow these steps right down to, not breathing on samples, making sure there's no air in samples, running sample ports for 5 minutes, making sure you're not touching anything, sometimes disinfecting your hands. And if you're measuring for other things, don't disinfect your hands, because it'll actually cause a problem with the organics in the sample. So it is not trivial, and unless you're trained well to do it, you can introduce bad data very quickly.
That's it's treating the water as the patient, and like you're trying to take that sample of the lesion, or you're getting the blood sample, and you don't want to contaminate it, because your point, and you're treating your patient for something they may not have, or you're not capturing what they actually do have. So that's a great call out there, Jeff. You mentioned when the light comes on, and we're going to come back on our next episode talking about what to do when that light comes on, when those alerts and those alarm levels are kind of ringing or blinking in our eyes there. As we wrap up this episode, though, I want to encourage everyone, if you have more questions around this monitoring piece, because it's such a critical part of this puzzle, like Jeff said, get everything else right, and you sample wrong, then the process breaks down. So make sure, if you're not already connected with Jeff on LinkedIn, to do so, and you can track down more of his contact information in the description of this episode. And remember that we're not done yet. We've got a couple more episodes in this series that we're going to continue this conversation from alarms. We're going to talk about corrective actions, talk about how to evaluate your existing program and whatnot. So a lot more to come on this water quality conversation. But we're going to wrap it today, and we're going to encourage you, like we do each and every week here at Beyond Clean, to keep fighting dirty.